Okay guys, we are on chapter 9, lesson 5, multiplication with the addition or subtraction method. Now we are still dealing with systems of linear equations, and last time we learned how to deal with something that had one of the variables be the same, like this. 5x minus y equals 12 and 3x plus y equals 4. We learned that we could add the two equations to eliminate one of the variables, solve for x, plug it back in, and then get the y to find the solution set. So we know how to solve these by graphing, we know how to solve them by substitution, and we know how to solve them with the addition or subtraction method. Now this time we're going to be dealing with a situation where the variables do not match up. They don't have the same or opposite coefficients. Instead, they look something like this. 4x minus 5y equals 23 and 3x plus 10y equals 31. Okay, notice 4 and 3 don't match up here, 5 and 10 don't match up. So what we're going to do is we're going to force one of these equations into an equivalent equation that will match it. So if this is equation 1 and this is equation 2, we're going to take equation 1 and we're going to multiply both sides of that equation by 2. Here's what will happen. I'll have 4x times 2 is 8x. Negative 5y times 2 is negative 10y. 23 times 2 is 46. This is an equivalent equation. This is the same equation as this. I multiplied both sides by 2, and that's legal. Then I'm going to rewrite equation number 2 here. Now, it's like what we've dealt with before. The y coefficients are opposites, so we can add them. 8x plus 3x is 11x. Negative 10y plus 10y is gone. 46 plus 31 is 77. Solve for x. We have x equals 7. Now we can go back to one of the either one of the original two equations and plug 7 in, and we'll get 3 times 7 plus 10y equals 31. 21 plus 10y equals 31 minus 21 minus 21. Y is equal to 1. So the solution to our original set of equations, system of linear equations, is 7, 1. Saw how we did that? We changed one of the equations to have the same or opposite coefficient. Let's do another one. Now in this situation we have 3a plus 4b equals 2 and 5a plus 9b equals 1. Okay, 3 and 5 don't match, 4 and 9 don't match, and neither of them are easy to change to match the other one. So what do you do in a situation like this? In this situation, all we had to do is multiply the first one by 2 to make it be a 10. But there's no corresponding change here. So what we're going to do is we're going to change equation 1 and equation 2. So let's pick the variable a to eliminate. We're going to multiply this one by 5 and this one by 3. And by doing that, we will end up with some matching coefficients. So here we go. 5 times each term here. So 15a plus 20b equals 10. Okay, now multiply this one by 3. 15a plus 27b equals 3. Now I have the coefficient of a is the same in both equations. So I'm going to subtract the second equation from the first equation. 15 minus 15 is 0. 20 minus 27 is negative 7b. 10 minus 3 is 7. Solve for b, and I have b equals negative 1. Okay, Then we take negative 1 and we substitute in for b here. And so I'll have 3a minus 4 equals 2. Plus 4 both sides. 3a equals 6. Solve for a equals 2. So this system of equations has as its solution set the point 2, negative 1. There's my answer. Yes. Okay. One final situation that could be complicating things for you. Look at this guy. Whoa. It's got fractions. Okay. That's no problem. No problem for us. What we're going to do, we have equation 1, equation 2. We're going to clear the fractions by multiplying each equation by the least common denominator of its denominator. So this one has a 3 in the denominator. So if I multiply this by a 3, it'll clear the fraction. This one has a 4 and a 2. So I'll need to multiply by a 4 to clear the fractions. So here we go. 5x over 3 times 3 is 5x. That's why we chose 3. Plus 3y equals 21. 4 times x is 4x. 4x times y over 4 is y. 4 times 7 halves is 14. Okay, so now we have equations that look like this, and we know what to do. When we have these, we're going to look at it to see which variable should we work to eliminate. And I would suggest we eliminate the y variable, because all I need to do is multiply the second equation by 3. So I'm going to rewrite the first one just for ease of work sake. And then I'm going to get 12x plus 3y equals 42. No, 42. Excuse me. Okay, then I'm going to subtract, because these are the same coefficients. So 5 minus 12 is negative 7x. Those are gone. 21 minus 42 equals negative 21. Solve for x. Then I've got x equals 3. Then if I come back up here and I put 3 for x, 12 plus y equals 14, y will equal 2. So the solution set for this set of system of equation is 3, 2. Done. Okay. Guys, you can always check your answers if you take the solution set that you come up with and put it into each of the original 2 equations. You should get a true equation. Okay, let me know if you have any questions and start your work.